Hi, everyone. Welcome to Unfiltered Flow ELSC, the podcast dedicated to the progression of the fluid power and automation industries. I'm Meghann Cook. That's Alan Burdette. Today, we are super excited to go global. We have Thomy Leibacher on. Hi, Thomy.
Hi, Megan. Hi, Alan.
Hi, Tommy. How are you?
Good. How are you? Thank you for having me.
We're super excited. This is awesome. So glad you could join us.
It's wonderful, actually. I hope my background is okay. This is my office at home. I have it at my basement, so it's a little bit messy.
No, it's perfect. That looks like where all the action happens. So that's what we want.
Yeah, Megan has an alternate location that looks something like that as well.
I
I
see.
do.
I should do this in the same way.
Well, Tommy, tell us. Let's go back to the beginning. How did you get into hydraulics?
I started my apprenticeship after school and in a company as a mechanical technician. My dad was engineer, mechanical engineer, and he did the decision. I followed through. So the company, they produced the big valves, and let's starting with size 6 up to size 250. Operation pressure like 5,000 psi, and the valves came in mostly materials like stainless steel, but also very sturdy, high performance alloys. By then, I was right away interested in testing and doing assembly of valves. That was, I thought that's the place where the music plays. I have seen engineers coming in and going out, checked our products. So by then we were a company with, let's say, 50 people, and we, the students, something like 20. So we were a huge performance and help in this company. So anyway, it was family owned. My boss and the owner, he was quite focused to demonstrate how you do things. If you get in trouble with something, he showed you how to take those tools in your hand and stuff like this. So I think it's the old way how you learn. So in the third year, I got the chance to help my boss to build a flow rig to test our valves. So it's the valves, by the way, were kind of new products. He started, I believe, 10 years earlier. Then I started in his company. So also he was learning every day a little bit. And as I said, I mentioned he designed the flow rig, and yeah, I got the chance to help him to put this together, all the pump, the piping, and the flow meters, where you can watch how the water flows through, stuff like this. With a lot of water, we get many times very wet.
Mm, That's a great way to
Yeah,
learn, though,
yeah,
isn't it?
yeah.
Right. And but I learned how to measure flow. And once we measured, we did some testing. A PhD engineer came in and checked on his valve he ordered from us, and then he saw what I tried to do, and then he explained a little bit better to me what I should do. So it was a quite interesting time to learn and add skills. I remember I got by then the first device for doing differential pressure measuring, because that PhD guy told me you have to make sure you have always the same pressure loss on your valve, because not you will measure something.
Right.
And my boss, he went out and bought a device from a company in the same city we were located. Funny thing was that owner of the pressure device company. I met him later in my life again. That's funny. And we did over a couple years some work together.
Mm, that's good.
So you meet always twice.
Mhm.
Right. Yeah. Yeah.
So, but also what I learned in that company, I got the skills to operate a spectrometer for leak detection and check the leakage on the valve. The spectrometer counts the helium atoms. They go through your seat, and that was something special, what I learned there. You can see, so the valves we did, they were more related to the chemical industry by then, and to the chemical industry and to the aerospace and aviation industry. At the end of my education, my boss, so you have to do this for 4 years in Switzerland. And after 4 years, you get a diploma. So that's how it works. You get all the skills how to mill, grind, drill, whatever it takes, and to do drawings, stuff like this. So at the
Right.
end of those 4 years, my boss asked me to do a repair job outside in a customer place. And I was very happy about this because that job brought me to South America.
Mm.
So the customer was Ariane Space on its launch center in French Guiana, and I had to do some repair on our valves. By then, Ariane was very new. There was no rocket flying by then. They installed everything by then, and like always in the hydraulics, the worst for all the valves happen in the first step when they push some fluid through the piping, you get all the dirt in your valves. So our brand new valves, they had to be repaired. And that was my job for a couple weeks. I was very proud and very happy about us. For young,
Megan loves foreign objects and hydraulics systems because that's how she made her living for many years.
Yeah. I was in charge of remanufacturing, so dry starts and contamination were my friends.
that's good. No, it's funny, but then when you do a repair job outside, you had to write a letter or so, or teletext. We called him text, teletext, I believe, and then you had to wait, let's say, 3-4 days. That's when you were off and had time to enjoy the swim in the sea.
Well,
So
little time off never helps. Little time off never hurts. That's for sure.
That's
Yeah.
right.
Hey, let me follow up here. You've spent tens of thousands of hours working in hydraulics, and you had mentioned earlier your age. I won't. You're still quite young,
thank you.
but you've spent a lot of time in hydraulics. So what gets you excited about it now, after having spent so much time in it?
Yeah. I have reading this and I was worrying about myself as well. So I'm still excited. I believe when I did the apprenticeship, I was highly interested in fluid mechanics because you get all the areas in this field of application, like you have fluids, you have steam, you just have everything, and then you have the design work on the parts, and you have the flow calculation in your piping and diameter openings. You have to calculate the spring and adapt the characteristic of the spring to your, let's say, your solenoid force change, stuff like this. So everything comes together, and so that was one of the important points, I would say. Never ending new things happened, and our customers in hydraulics are people, they produce excavators or drilling equipment or milling equipment or grinding equipment or trucks. You have brake systems, you have clamping system, you have lifting system, you have lowering system, and it's every time a different, let's say, situation you meet. And so that was one of the thing I was most interested. And I like to do new things. So even today, if you call me now or to tell me, Tommy, come over and we have to do something, I on my way.
Let me ask you this. You've worked at both in Europe and North America. So, what's one thing that you think each market does well when it comes to engineering?
Ha, that's an excellent question. I, I lost my heart in the US, so that's terrible, actually. It's a terrible question for me. So I love doing the work with people in the US. So it doesn't matter which region and which place. US was always a place for me where exciting things happened. I met a lot of people. They they tried to do their best to make the utmost outcome which would be possible at that time. And I love to see the teams working together and doing new things. That's what I love most. My experience in the US met many exciting teams, highly skilled engineers. So I remember when I like in the US the way they write down tasks and checklists. I never experienced this way. They write a real straight and clean checklist where you can find any niche where could be happening a failure or mistake or misstep, let's say. That's something I never have saw in that kind of quality. So that's the US for me. Every time new things, when you have an idea, you call somebody and yes, let's do something. And that's an easy start. It happened to me a couple times. The biggest hurdle for me was the language. The first time came to the US. So a lot of great engineers when you so there are so many products like the servo valves produced by Textron in the old days. Today it's part of the Woodward, I believe, group. And they got a contract from the government in the US in the 60s to develop servo valves for aviation in the aircrafts in it. And excellent designs, even today. So I had the chance to meet some of those engineers once. So just great experience. So that's what happened to me in the US. And I had got a chance in 2005 to meet a Swiss company in the US. It's called Hydraulics Electronics.
Mhm.
They in Switzerland, I would say it's the top hydraulic company when it comes for customized valves, high quality design. The guys know very well how to design and calculate whatever it or what it has to be calculated. So I worked a little bit there. I learned a lot. US, a lot of good people, but also production companies. It's get a little bit longer about the US, but I have to do this. There are companies like solenoid companies. I remember in Indiana, he did once a couple solenoids for me. He helped me to do the calculation in the right way. But it also was a family-owned company, and then companies like Parker, Lake Erie. Really, I was a couple times in that outstanding place involved in projects. Those people were so skilled when they did the starting meeting. They know very well to ask the right question to uncover your weakness or missing skills to make sure at the end you will meet the results. Always to meet the results as a team. So that was always impressive for me. So in the US. Now, okay, that's the US, Europe. It's we have wonderful companies in Europe. Great productions company, Switzerland, my home country. You will find people they know how to to drill the 10,000th of an inch and repeat it, repeat this and repeat it. So they know how to do this, and even the circularity stuff like this in the 10,000th of an inch. It's quite impressive. The difference between here, I believe, and the US, their skills are a little bit overlapping. So every person knows a little bit more of the job of his colleagues close to him, and you can see this as a picture on the task list. So it's always a little bit an overlapping. I believe that's their way to protect against failure or mistakes. I don't know, but that's the main one of the main differences. But their Switzerland, their character is it remembers me a lot to the Midwest. They are people are kind and very skilled, calm. They know what they are doing. They like to have a good life. Austria, especially, my boss, he did piping, big pipings for steam pipes in power plants to feed the turbine.
Mhm.
And I was working as a sales manager. And I had to do an offer to a company I, uh, in Venezuela. I don't know if I should say this, but I did it all right. So we Austria, they have excellent services from the government when you have to do a contract with a country like Venezuela. You get great help in all the details. They know about the law, how to do and handle this. That was something which was quite impressive for me.
Mhm.
Yes, then, but also think about water management and water project countries like Netherlands. As an example, all the equipment they do for flood and high tide protection, they are really capable. I believe there are still today some people in New York. In the meantime, and not in the past, it was Netherlands. Today they are in New York and they're doing high tide production
Mhm.
systems. So, but in my hometown, Zurich, we have a long tradition in turbine engineering dating back to former SOVs. They produce turbines. They are quite famous.
So
So, I believe both places are needed in this world. It would be boring to miss any of them.
we all have something to offer, right? Just
Right.
a little bit different. So, in all your years, do you have a favorite application that you've worked on or most interesting application?
I was thinking about, and there was a brake systems in the 90s. You know, when you do the material for a coat or stuff, you have to prepare the single wire on it, and it takes machine, and you have to keep the tension of the wire on certain level. And they need brake system, big brake disc brakes they have. And we had a company in Switzerland, and they were asking for a new pressure control system. And I remember about it happened in the 90s, and I remembered about a valve designed in the 80s by Parker. It was called pulsar valve. Do you know about this? It's pulsar. It's actually a bang bang valve. It works like a proportional valve. You control the switch in time and the switch off time, and those valves are very speedy. And you have a load valve and an unload valve, and so you keep your pressure level or pressure on a certain level. So Parker did stuff like this in the 80s, and already, I believe, in the 60s, there were some in invention from some companies in Europe. I thought in Sweden was one company. So, but then we did it by using poppet valves, and because that time my employer, he had some. We did all the he did all the solenoids and the valves. It was an easy thing for us to produce a valve where you get more speed. And we did the very first application and brake system. We had our first own. The company had our first own digital electronics. They My colleagues in the electronics, by then, they were highly motivated and interested to develop those things. But in the 90s, I have to tell you that those digital electronic was like very slow. Like our old computers, you had to wait. So the limit of our being accurate depended on the speed of our digital electronics. But by then we made it, and we kicked our competition with their servo valves out and replaced them with a Puppet PMW controlled valves. So that was a highly fun application, and as a team experience, because it involves solenoids, it involves software development and hardware development. My colleagues, they did an incredible job, and on the top, our boss, he allowed us doing something like this. It was highly risky. So that I will never forget about. But yes,
This is a good point to ask this question because you talked about different. So when you look at how you design valves, think about when you first started designing valves, how you design them now. Has technology changed the way you do that? And if so, how?
the work we're doing with by using hydraulics doesn't have changed. It's still the excavator who moves some dirt from left to right. So we
Right.
just added some stuff in it. I'm not so sure what we really need. I believe the work we try to do by using hydraulic controls still the same. We like to be more accurate, having more speed, keep us more energy efficient, and stuff like this. And when it comes to design, most important, you still have to have the skills how to calculate. You have to understand what's the shortest point of 2 points, and you have to understand how to calculate the spring by hand. But in your workflow today, it's it's exciting stuff. We have the 3D CAD we are using for 3D models. We have assembly we can do. We have the whole project management, what we got over the last couple of years, especially when we got COVID in it, all those tools like Teams, like Planner, like whatever, to-do lists, all those things are today implemented in our project management and our drawing work, and and our workflow, how we design parts. So I believe that's the the major change. But I'm still doing first sketch by hand. I have my drawings table. I write by ink. I tried many times. I believe I started with I had my first smartphone, I believe, in 2000. It was a Motorola PM200. It came with Windows 2000, I believe. So not very stable. I had a cousin, was working by then in Motorola, so I had a, so I know what they are doing. That's right. So, but those tools, those smartphones, they were far away of the smartphones we are using today. You know, by having this, I can leave my country. I don't need more. So,
Mhm.
so that's what happened to us, all of us.
Mhm.
Has
This is true.
So that's the I believe that's the biggest difference. I remember my dad when I got my first ideas about CAD when he bought a US software. It was called by then General CAD. I don't know if you know about this. It was actually a 2D system which was capable to do the item lists and everything out of your drawing. So, but then we have the big digital tablets where you click on your items or what you like to insert in your drawings, stuff like this. So that was in the 80s, and today it's a different world, but it took 30 years.
Mhm.
But the engineers by then they know very well what they are want. So nothing had changed.
Well, what about this? What's one thing that you wished you knew about the hydraulics business when you were first starting out that you know now?
Yeah. So that's an easy one. It's all about standards and the languages. You have to really we have to understand the different standard like ANSI standard, the AISI standards, the ISO standards. We have to do our design in inch and in metrics. It doesn't matter, but we have to the fullest understand how to do this. So there should be no hurdle between. So that I believe that's the most important. And I think today I'm sure English it's quite important in engineering. You have to talk the language and you have to understand the language to understand the standards to do the right decision. So languages, that's very important. English, that's very important. We still see in design and standard lines of hydraulic cylinders, hinge product lines like 1,000 psi, 2,000 psi, 3,000 psi, and in bars, they got their 160 bar stuff, and those 210 bars, those were translations from the PSI. So, and calculations, funny things, it's for me easier to do in the inch and time stuff, than doing calculations. And I had one time a spring, I followed prescription of the design routine from the ANSI and the US, and I could change a little bit the values, just slightly. But the result was I got my spring in my valve. And then when I talked later in Switzerland with the engineer, they told me it doesn't work, it doesn't fit in. And I told, yes, it fits in. So that's the difference.
Mhm.
So sometimes there are difference in a few, and that kind of difference, it's just the right way you have to do things. So that's what I believe that's something you have to be aware how important that could be for our technician and engineers. And then all the, you know, doing design and the dimensions, follow the standard preferred values, then fraction still important. You can do a fraction calculation even without battery or electrical power. So it's a huge help.
Well, so what piece of advice would you give a young engineer starting out?
So you have to look for a great teacher. I believe that's most important, where you can follow him, learn about how he about his workflow, how he's doing things, how how are the validation of the parts, how we do the sturdiness calculation, stuff like about the materials. That's a question of experience, I believe. When somebody choose the materials, you have to be careful in choosing your teacher. I met my teachers, a good teacher very early, and then later on with Connie Kosorek, I spent, I believe, 4 years with him. By then he was already in his 70s. And when met him the first time, I was asking him, would you design a new product line with me? And he told me, yes, we could do this. So straight for us. So that was wonderful. And then Hannes Keller, he's the owner of Keller Pressure in Switzerland. He is an excellent scientist, and he believes in the future. Young people invest your skills in new things and doing new things,
Mm,
and wonderful things will coming back to you. He was a great man. I am that was actually the man who produced the first measuring device for my pressure, device I mentioned when we started our conversation. So I met him
yeah.
a second time. I did some work doing when I started the new product line. I did this in cooperation with Mr. Kaller and also with Connie, so it's exciting teachers. Wonderful, just wonderful. So that's my wish for young people and young engineers.
Mhm. Great. It is very good advice. This is an off the books question, but I have to ask. Do you run 7 days a week?
Yes. And no, actually on Friday, not Friday today, this morning, it was farmers market in Zurich, and I got early up. He opens at 6 a.m. and you get fresh vegetables, flowers, fresh bread from the bakery, uh, and you meet great people, so farmers. That's a single day I'm not doing my running. Or
Mm,
when you
okay.
get a lot of rain, then or when it's too cold.
Yeah. Yeah, it's impressive. You're, uh, you're running there, and it's how many miles a day do you do?
To do not that much. It's 6 miles, I believe.
Not that much. Really?
You know, I can do better. I can do better. You know, I can do better. So I had an accident and I made a tournament in the hospital. And after that, it was a wake up call for me, and I'm doing my exercise.
Wow,
And I love
that's impressive. Yeah, good for you. I don't
yes.
think I'd be able to walk 6 miles at this point, so running it is very, very impressive. I'll tell you that.
Yes, and you get a gift. You get some calories. You can eat
Mhm.
additional ice cream. I like cookies. I like cookies, and I have candies in my oven. So Francisca, my partner, she told me, "Don't eat any candy."
Do you just tell her that's okay? I run 6 miles, 6 days
Yes,
a week, so I burn it off.
so you
Well,
never
Thomy,
can.
thank you so much for joining us. I know it's late over there. You're about ready to call it an evening, I'm sure.
Thank
So
you.
we
Thank you.
really appreciate you coming on.
Thank you taking time for our conversation. You have seen all the valves I'm doing. They are brand new. It's more than 250 different type of valves. I have, let's say, like 12,000 files. They are ready for industrialization and production. I'm looking for a young, agile, and lean company and young engineers. They are ready to start a new business. We are highly competitive. Our slip-in cartridge, they go up to 9,000 PSI. So if you know somebody, they are interested, I'm open. I think a project we could start in the US or in Canada or in Switzerland. Everything is in English and it's easy to do this. So if you know somebody or if you have to change to connect us, so it would be wonderful.
Yeah,
You get some
absolutely.
provision.
Yeah, that sounds good. We will let you know. Thank you again for coming on. It was
Thank
great to
you.
have you.
Thank you. Thank you, Megan. Thank you, Alan. Thank you for taking time. Be safe.
All right, you too, Tony.